There is a hollow tower of mud brick standing in a desert where the summer air climbs past 105 degrees and stays there for weeks. It has no fan. It has no motor. It has never touched a power line in its life. And on the worst afternoon of the year, the room beneath it is cool enough to be comfortable, and the water stored a few feet away is sitting just above freezing. You have almost certainly seen this tower before. You've seen it in a thumbnail, in a slideshow, in a dozen videos, and nearly every one of them told you the same thing: that this is Roman engineering, a lost secret of the Caesars. That's the first thing wrong with the story. This tower is not Roman. It missed Rome by an entire empire and about 1,500 miles. Its real name is Badgir, and it's Persian. Versions of it were catching wind over the rooftops of the ancient world centuries before Rome was even a power worth the name. The Romans were brilliant at moving heat around. They never built this. What they never built is a mud chimney that could passively cool homes and chill water across an entire city without spending a single watt. And then hand that same trick down for something like 2,500 years before the people who perfected it quietly walked away from it. That last part is the real mystery here, because the city that invented this thing is now full of the exact machines it made unnecessary, humming away on the grid, and almost nobody there can tell you why. To understand what was thrown away, you have to feel the problem it solved. Picture the place: central Iran, the high desert, a city like Yazd sitting on a plateau where the sun is a physical weight and the nearest cool relief is hundreds of miles in any direction. There is no coastline to soften the afternoon. There is no forest. For much of the year, the outdoor temperature is not a discomfort. It is a genuine threat, the kind of heat that kills people who guess wrong about shade and water. Now strip away everything you reach for when your own house gets hot. No air conditioner, no refrigerator, no electricity at all. That is the design brief the builders of this city were handed, and the honest version of the challenge is brutal. Keep a family cool and keep their water and food from spoiling through a summer that wants to cook both. Fail, and you don't get an uncomfortable night. You get sick, or you get robbed of the water you spent a fortune to reach. Their answer was to stop thinking about the house and start thinking about the wind. A Badgir, stripped to its bones, is almost insultingly simple. It is a tall shaft open at the top with vents facing out over the roof line and a channel running straight down into the rooms below. Wind hits the openings, gets funneled down the shaft, and pours into the living space as a moving breeze. Hot, stale air is pushed out the other side. On the surface, that is the entire idea: a scoop for the sky. If that were all it did, it would be a clever gadget and nothing more. What makes it an engine is that it runs on two separate forces at once, and the builders exploited both without ever writing down the physics. The first force is the obvious one: wind pressure. When a breeze slams into the tower, it builds up pressure on the windward face and pulls a slight vacuum on the other side, and air is dragged through the building from high pressure to low. Straightforward. The second force is the one that turns a scoop into a machine. Warm air inside the shaft rises on its own. Hot air is less dense, so it climbs the tower and escapes out the top. And as it leaves, it pulls fresh air up behind it through the base. Engineers call it the stack effect or buoyancy. The tower breathes even when nothing is pushing it. And that is the detail that should stop you, because it inverts what you'd expect. You would assume a wind tower fails on a dead still day when there's no breeze to catch. It's the opposite. On a hot, windless afternoon, precisely when the outdoor air is deadest and you'd expect a wind scoop to be useless, warm air keeps climbing the shaft and spilling out the top, and as it leaves, it drags fresh air up through the base behind it. The tower keeps breathing after every breeze has died. It has no off-season. But a breeze, even a cool one, does not explain water sitting at near freezing in a desert. A tower that only moves air can make you feel better. It cannot make ice. For that, the tower had to stop being a single object and become one organ in a much larger body. This is where cooling a whole city stops sounding like a slogan and starts to make physical sense. Not as one giant machine, but as thousands of buildings running the same passive trick at once. It's also where nearly every retelling quits early, because it only ever shows you the tower. Run underneath that desert city and you find a second network that never sees the sun. The Qanat, a hand-dug underground aqueduct sloping gently down from the highlands to carry cold groundwater into the city through miles of tunnel. In Yazd, that buried river system runs something like 43 miles and sits around 100 feet down, deep in cold, damp earth that holds a steady chill no matter what the surface is doing. Now connect the two. The Badgir doesn't just pull air from over the roof. In the fully developed version, its shaft opens down into the cool, damp underground space the Qanat feeds. Air gets pulled down the tower and drawn across that buried channel, passing over cold stone and the chilled water the Qanat carries before it ever reaches a person. It arrives not just moving, but genuinely cooled. Air that has been dropped 100 feet into cold earth on its way to your floor. The tower is the lungs. The Qanat is the bloodstream. Neither one alone does much. Plumbed together, they cool a house so well you'd swear something was running. Bolt on the last two pieces and the machine is complete. Sitting over some of those underground cisterns, the Ab Anbars, great domed reservoirs holding the city's drinking water, are more wind catchers, and they are doing something that sounds impossible for a mud structure in a furnace, keeping stored water startlingly cold, far below the desert baking overhead, straight through the summer. The moving air strips heat off the water surface by evaporation. The buried mass holds the cold, and the reservoir stays fresh and drinkable for months. Push that same logic one step further, and you reach the Yakchal, the desert ice house, a thick-walled dome shading shallow pools of water, engineered so precisely that it didn't just store ice hauled down from the mountains. In the right conditions, it made ice in those shallow pools in a region where the afternoon roars past 105 degrees, but the dry desert night can crash all the way to freezing. Shaded from the day and left open to the cold, the water sheds its heat straight up into the night sky, and by dawn there is a skin of ice on a pond in the desert. A civilization with no electricity built refrigeration out of mud, water, and the temperature of the dark. That is not a folk legend anyone rounded up. It happened at scale for centuries, at which point a reasonable person gets suspicious. This is exactly the kind of story that grows in the retelling, the ancient wisdom that supposedly humbles modern science. So it is worth knowing that modern science went and checked. Over the last few decades, researchers have wired real badgers with sensors, built scale models, run them through wind tunnels, and simulated the airflow with the same computational fluid dynamics software used to design jet engines. The name that comes up again and again is Mehdi Bahadori, an engineer who spent years dragging this primitive technology into a lab to see whether it actually did anything. It does. The measured results are not romantic. They're just solid. A wind catcher paired with evaporative cooling has been clocked running roughly 15 degrees cooler inside than the outdoor air when that outdoor air is above 95 degrees. Field monitoring of a traditional house in Yazd recorded the tower alone pulling the indoor temperature down by somewhere between 1 and 8 degrees depending on conditions. In the right conditions, some configurations replace the entire volume of air in a room dozens of times an hour. A ventilation rate a modern mechanical system would be pleased to hit. The mud tower does it with no moving parts and no bill, so the physics is real, the performance is measured, and the design is old almost beyond reckoning, which sets up a genuine puzzle that most people never even notice. The technology is believed to be roughly 2,500 years old, its roots reaching back toward ancient Persia. The oldest Badgir still standing is only about 700 years old, roughly 14th century. There is a 1,800-year hole in the physical record, and it isn't a mystery of lost knowledge. It's a mystery of material. These towers are mud brick and timber. They are magnificent and they are fragile. And a mud tower left alone doesn't last 2 millennia. It slumps, it cracks, it gets torn down and rebuilt in the same spot by the next generation. So the idea is ancient, while almost every surviving example is medieval or newer. You're looking at a 2,500-year-old design wearing a 700-year-old body. Yazd wears more of those bodies than anywhere on Earth. UNESCO lists it as a World Heritage City, and it's earned a nickname you rarely hear applied to a whole town, the City of Windcatchers, with something on the order of 700 of them still rising over its rooftops. The tallest is a purpose-built cooling tower at the Daulatabad Garden that climbs about 110 feet. Roughly a 10-story building made of adobe and wood whose entire reason to exist is to move air downward. It is still standing. It still works. And here is the detail that quietly demolishes the idea that any of this was primitive. These towers were not a standard part you stamped out and dropped on every roof. Every one was tuned to the wind of its specific town. In Yazd, where the desert wind shifts direction through the day, the wind catchers have 4 or 8 sides so they can grab a breeze no matter where it's coming from. Travel about 30 miles to Maybod, where the wind blows from one reliable direction, and the towers change, short and pointed one way, because catching the wind from any other direction, there would be a waste of brick. Same technology, re-engineered street by street, town by town, tuned to the local sky like an instrument. That is not folk craft. That is engineering done without a single equation on paper. That tuning reached further than a single town. Carried along trade routes and pushed outward by empire, the wind catchers spread across the Persian-influenced world, down to the shores of the Persian Gulf, west into Egypt, east as far as Pakistan and India, and everywhere it landed, local builders bent the form to the wind and heat they actually had. But there was one thing it could never outrun, and it explains why you don't see these towers over Miami or Mumbai. The part of the system that made air genuinely cold rather than merely moving runs on evaporation. And evaporation only pulls heat out of the air when that air is bone dry and thirsty for moisture. On the high desert plateau, that's most of the year. Drag the same tower into somewhere humid and the trick simply switches off. The air is already saturated, the water refuses to evaporate, and the cold never arrives. This was never a universal machine. It was a desert animal, exquisitely adapted to one kind of sky, which makes what happened to it in its own homeland stranger still. So we arrive back at the question planted at the start, the one the title asks, and almost no video actually answers. If this system worked, if it cooled homes, chilled water, made ice, and did all of it for free, verified by modern instruments, then why did the people who spent 2,500 years perfecting it abandon it inside a single lifetime? The comfortable answer is that we simply forgot. That's not the real one, and the real one is more unsettling because nobody chose it. Nothing was banned. No law was passed against the bad gear. What happened is that cheap electricity reached the desert, and with it came the air conditioner, a box that delivered on demand at the flip of a switch everything the tower delivered on the wind schedule. The tower needed a breeze, or at least a temperature difference, and a builder who understood the local wind. The air conditioner needed a plug and a monthly payment. For the first time in 25 centuries, staying cool no longer required understanding your own sky. It required a utility account. And once thinking became optional, the thinking stopped. New buildings in Yazd went up in cement, in styles imported from countries that share none of its climate. Sealed boxes that trap the very heat the old city was shaped to shed, then bolt an air conditioner to the wall to fight the problem the building just created. The heritage officials who watched this happen use a blunt word for what was lost, forgotten. Not defeated, not disproven. Forgotten, because a machine made the knowledge unnecessary, and one generation quietly declined to pass it on. There was a real flaw in fairness, and it's worth naming because it's small. A traditional badger had no way to shut itself off. It has no valve, no damper, no door on the sky. So on a cold night, it could overcool a room, and on a dusty day, it fed the interior a slow trickle of grit along with the breeze. That is the honest weakness. It is also the kind of problem a modern engineer solves in an afternoon with an adjustable louver, a shutter you can close. The tower was never broken. It was unfinished by about one part, and instead of adding that part, we unplugged the whole idea and plugged in a compressor. No one sat in a room and decided to kill the wind catcher. The switch was just easier than the wind, and easier won. Except the story doesn't end at the eulogy. which is the part that should genuinely change how you look at that mud tower. The bed gear is already coming back and not as a museum piece. Walk into Masdar City in Abu Dhabi, a from scratch experiment in low energy living, and you'll find a modern wind tower pulling desert air down into a public courtyard on the same principle a Yazd builder used 1,000 years ago. Visit Zion National Park in Utah, and the visitor center is cooled in part by wind catcher style towers that let it skip most of the mechanical air conditioning a building that size would normally demand. Council House 2 in Melbourne, one of Australia's most studied green office buildings, breathes through the same logic. Engineers now have a clean phrase for it: zero energy cooling. And they are actively pitching it as a serious answer to a hard number. Global demand for cooling is on track to roughly triple by 2050, at exactly the moment we can least afford to meet it by burning more fuel. Which reframes the whole thing. The tower in that thumbnail was never a Roman relic, and it was never really lost. It was a working, measurable, refined piece of engineering that a civilization built by hand, tuned to its own wind and used to cool its homes and chill its water across whole cities out of nothing but air and cold earth. Set down not because it failed, but because for one cheap, electrified moment it was easier to stop thinking. The knowledge to build one still exists. The physics never stopped being true. The only thing that ever really disappeared was the reason to bother. And on a planet that's running out of ways to keep itself cool, that reason is walking right back through the door.